Hey, this is Mr. Montgomery, and I will be going over your video today. We will be going over the commutative property as well as the associative property. So pull out your notes, and we'll get started. The word commutative means to move. The commutative property of addition or multiplication means you can move things around in addition or multiplication problems without changing its value. For example, in an addition problem, we can change the order up so it's easier for us. So here we have 3 plus 4 plus 5. Well, if I'd like, I can change the order up to 4 plus 5 plus 3 using our commutative rule. Also, in multiplication, I can also change the order because it works for addition as well as multiplication. I'll go ahead and underline those for you. Here, as you can see in our example, we have 3 times 4 times 5. Well, using our commutative rule, we can change the order and multiply 4 times 5 times 3. You may be thinking, why would we ever want to use this? Well, let's see. Let's simplify this following page and find out. All right, now let's use our commutative property to simplify this expression mentally. The first expression, we have 5.6 plus 7.8 plus 4.4. Now let's think, is there any way I can simplify this to make it any easier by using our rules? Well, if I move around our 7 and our 8, and I have 5.6 plus 4.4 plus, go ahead and put my 4 back up there, 4.4 plus 7.8, it makes it a little easier to see using mental math. 5.6 plus 4.4 add together pretty nicely. These two add together to give you 10. Our 0.4 and our 0.6 add together nicely, as well as our 5 and our 4. Now we have 10 plus 7.8, and that'll give us 17.8. If we go over here and we use our commutative property on number 2, we can change these around. We'll stick with our 3 seconds times. What would be the best one to put next? Well, I think it's easier to put 2/3 times 5/7. Now we can easily see that our 3's will cross cancel, and so will our 2's, leaving us just 1/1 times 1/1 times 5/7, which will give us an answer of 5/7. So that's why we would use our commutative rule. Now moving on to our associative property. Associate means to join or unite. So, the associative property states that numbers can be grouped in different ways in an addition or multiplication problem without changing the value. I'm going to go ahead and underline in an addition or multiplication problem. For example, in this problem, we're grouping our 3 plus 4 plus 5. We can also group our 4 plus 5. So here, we're grouping these two. But since this is all addition, we can use our associative property and we can associate two different numbers. Now let's go on and see how this applies to multiplication. In multiplication, if it's all multiplication across, 3 times 4 times 5, we can go ahead and group these up differently if we like using our associative property. So here we have, let me fix that. Here we have 3. All right, guys, we have some technical difficulties there for a second. But anyways, back to our associative property in multiplication. We group together our 3 and our 4 in this one, whereas here we group together our 4 times our 5. And we can do that. We can change them up because we are using the associative property. Now, why would we use this? We would use this one to simplify a problem, just like our last rule. So, if we want to put that to practice, simplify the following expression mentally. If you would like, you can pause the video and you can simplify this in your head right now. I'm going to go ahead and work it out. We have 2.8 plus 7.9 plus 1.2. Well, we're going to think in our heads, is there an easier way to group these that may make mental math easier for me? For this one, we say yes. I can make it easier by having 2.8 plus 1.2 by using our associative property to associate two different words, or letters here. Numbers, guys, not letters, are words. Plus our 7.9. Here, we would have 4, 2.8 plus 1.2. We can do that in our head. Would give us 4 plus 7.9. And we can solve the rest out if we'd like. But we used our property. On number 4, with multiplication, we would associate two different ones here. We'd think to ourselves, what would it make it easier? What would make it easier for me to associate these numbers with? Well, I'll go ahead and group up. I'll move 3/8 outside of our group. And now I'll just go ahead and move 2/5 inside our group. As I do that, I see that our 2's cancel. So do our 5's. And we'll be left with 1 over 1 times 1 over 1. So we'll have 3/8 times 1 over 1. And that will give us 3/8. So that's exactly why we would use our associative rule. Now, on your own, practice using these two problems. Use your associative and your commutative rules, or properties, whenever possible. Now, if you want to try these right now, pause the video and go ahead and work them out. I'm going to go ahead and work through them with you as well. So, how can we make this first problem easier? We have 4.7 plus 11.9 plus 3.3. Well, if we use our commutative rule and our associative property, we can go ahead and take our 11.9 and switch that with our 4.7. So we'd have 11.9 plus 4.7 plus 3.3. You'd be able to work inside our parentheses now and do that first, which would give us 4.7 plus 3.3. That would give us 8 plus 11.9. We can easily add these two together, which will give us 19.9. Now let's go over to our next problem. we have 4/9 plus 5/11 plus 5/9. Using our commutative rule, I'll go ahead and change the order. I'll keep my 4/9. I'll go ahead and place 5/9 in the second spot, plus our 5/11. We already have a common denominator for these two, so I can add straight across there. 5 plus 4 gives us 9 over our common denominator, which is the 9th, plus 5/11, or 5/11. 9 over 9 is equals 1. So 1 plus our 5/11. 1 equals 11/11. So we can have our common denominator. So we have 11/11. Make this a little easier to see for you. 11. Okay, so our 11/11, which equals 1, plus 5/11 equals 16/11. Now we could easily solve that problem by using our properties. If you guys want to rewind those and replay them so you can see them again, go ahead. All right, guys, that'll be the end of your notes, but we're going to review a couple properties for you before class tomorrow. Our identity property of addition. So the key word here is identity. When you see that word in the property, that means we're going to keep our identity. In this case, our identity is x. So we're going to have to think, what can we add to x to keep x? So what plus something means you keep your number. The only number that's possible to add something to is 0 to keep the same number. So x plus 0 equals x. This holds true for any number. If I have 1 plus 0, my 1 still keeps his identity as 1. If I have 2 plus 0, my 2 keeps his identity as 2. We're going to use our knowledge about our identity property and apply it to multiplication this time. We have x times 1 equals x. X still keeps his identity. So if we have 2 times 1, our 2 will still keep his identity as a 2. So when we're multiplying, if we multiply another number times 1, our number gets to keep his identity. Now, here we have our inverse property of addition. Our inverse property of addition means we're going to add the opposite number to equal 0. So here we have x plus negative x equals 0. So if I was to apply that to actual numbers, I'd have 2 plus a negative 2 would equal 0. So inverse property of addition, we're always trying to get to 0. And we can do that by adding the opposite number. Our inverse property of multiplication, we would flip and then multiply. So on our inverse property of multiplication, here we have x times 1 over x equals 1. Our inverse property of multiplication will always equal 1. So if we want to stick with our theme and keep our 2's, we can multiply 2 times 2 flipped, which would be 1 over 2, which will equal 2 over 2, which equals 1. And that holds true to any number. If you multiply a whole number times itself flipped, you will equal 1. And that concludes our notes today, guys.